what I can say is the next wave that is coming up is the quantum computing, and we all have been witnessing that since Google has launched their Willow chip, or IBM has been working since decade onto this research. And what generally happens is there are cloud providers like Google, Microsoft, IBM, and so on. And there's a major problem as a vendor lock-in. And all of these quantum computers have a different processing capabilities. And just to give you a heads up, quantum computing uses different laws of physics, which is the superposition and the quantum entanglement, which is completely different from what our laptops and what our PCs use. So just to give a heads up, say for example, you need to search a string in a particular very large search space. So what our normal classical computer will do is it will just go in a particular way, it will find or not, and it will come back and find a different way. So in quantum computers, you explore all of the pathways at a given same time. So what problem that I'm tackling over here is, what if we create a chain, and a chain of various peers, and all of these peers advertises their quantum capabilities, and the entire chain becomes a quantum computer. So you are coalescing the Azure of Microsoft, IBM Cloud, and Google Cloud as well. So we'll proceed ahead with the demonstration.
Thanks, Soham.
I hope my screen is visible to everyone. Can anyone acknowledge me?
Yes, it's perfect. We can see it.
So yeah. So let's go to network first. We can see that we have our couple of nodes that have been spinning up and running up. And the small dots that you can see is the actual data exchange between these nodes. And there is no one single coordinator node which coordinates with all of these peers, but itself this is a pure decentralized peer nodes, and it advertises the capabilities using the GossipSub. And we can see that these are the peer IDs which are being in the node. Let's click and see what this contains. And we can see the peer ID and all of the metadata. When was the first scene? What was the last scene? And when this peer node came up, and the network addresses, and what this particular peer has to give to the entire network. What we can see is the bell pair C naught and the CZ. These are basically the gates, just like our classical computer inside a gate, which has the AND, NOR, and NOT gate, which is made up of various transistors and various circuits. So these are the analogous to the classical computer, which has the normal gates, and the same gates are being drafted over here as bell gates, C naught, and so on. And we can see that we have a total active peers, and my own browser acts as a one single node so that I can connect to any clusters. Say, for example, if I have a cluster in US East 1 and I have a different cluster in AP South 1 cloud. So I'm flexible enough to connect any one of the clusters and run my quantum computations and so on. So let's move ahead with the lab. And say, for example, if I want to go ahead and run a quantum circuit, this is very much same as how we are designing chips, hardware, or the transistor circuits and so on. But here we use softwares to design circuit as a, and we call it as quantum circuits. This is just a same as Python algorithm, which will be just running onto a quantum computer. So let's go ahead and run it. Meanwhile, this is being running. Let's go and see the logs, and we can see that our node is being requested by a particular peer ID, and this peer ID has accepted our request, and so on and so forth. We can see that a conversation between the entire distributed network is happening. So we can see that this program is completed, and let's go to see the quantum details. Here we can see the quantum circuit which we have compiled, and it has given the states. Uh, It is very much as how we represent our 0 and 1 states, but here we represent into a block sphere as to what state does it has, and so on and so forth. So in a distributed environment, we don't execute one single circuit onto a particular peer, but we divide a circuit in such a way that all the fragments become an independent entity, and all of these entities are being sent to process on a distributed peers. And say, for example, if I click on this particular fragment, it has been executed on a particular node over here as a peer ID. I hope the font is visible to everyone. Yeah. And let's go ahead and now the most famous implementation is the pharma talking. And we all have been a victim of COVID-19. And we saw that the to found a drug, it takes a couple more years, and it requires a lot of computations and a lot of intelligence from the chemist and so on. But we have done an experiment where where we cut the processing time to a half. Let's take an example of a particular protein that is 2AZ5, and you all can get the PDB ID onto a PDB bank dataset, which is globally available. And we can just go to discovery. That is, I want to discover a drug which can target and neutralize this protein. And I'll go ahead and I'll add some iterations and some candidate count as how many drugs that I can reproduce, which has the capability to neutralize the protein. Now I'll go to submit this pipeline, and now I can see the structure of protein over here. And on the right hand side, I can see all the logs that are being going on in the distributed environment, and I can clearly see my protein structure. And if I just go to the surface, here we can see the various logging, the various docking of our ligand, and we have seen that we have given candidate score as 300. So it will exercise 300 different chemical structures, molecules, which will try to dock onto a protein structure. And this is all happening onto a distributed compute environment. And it will take some time, as it approximately takes 5 to 10 minutes. So we will leave this thing over here, and we will go to the next thing as a vault. So what is a vault? So say for example, you and I are in a different lab in a different countries. So I want to share this particular experiment with you, with all the logs, with all the data that I've collected, and all the experiments that you can reproduce onto this platform. So using the IPFS, we pin this particular service and the experiment so that you can reproduce it, and I can give access to a global pinning so that everyone on this network can access this experiment, can cite my experiment, and pub- and publish the experiments or papers and so on. And we can see that our experiment is over here is completed, and we can see that the different energy graph of the 300 iterations that we found out. And one of the best drug, or the best and the most stable drug that we can found out is the this particular ligand structure. And this is the drug that we have been using to tackle or any diseases which is caused by a particular protein structure.
In the paucity of time, just if you could share about the IPFS and the libp2p part, like how this is getting saved. We have Neha's
Sure.
presentation. Would love if you can, while this is getting generated, just share that. I think you have great.
Yeah.
Absolutely.
Yeah. Yeah. So in the browser, we broadcast our message that hey, that I want to run this particular experiment, and using the GossipSub, all of the peer and the nodes try to advertise what services that they can offer, and with what fidelity scores that they can offer. And each of these nodes, they uh, they use Academia DST for the discovery, and Bootstrap as well as the backup if any of the protocols gets failed. And we can see that this is the uh, live pinging of all the nodes to see if any node is live or not, and to store all the peer nodes or the peer data. We have been using the local pinning service of the IPFS, and to store the experiments and to save the experiments or to share the experiments, we have been using IPFS as the Inata services. And if you have a very little idea about what all these things are on and what are the protein structure at that time need to experiment on, and here are the agents which which will work for you. That here is a demo that I won't take much long time over here. And over here you can just talk to the agent and you can discuss what are the experiment that you need to talk about. And all of these agent are situated onto a pilot P2P peers, and they talk using the GossipSub protocol. And it uses the agent kit uh, library to exchange any transactions or any funding that a particular research proposals required or not. So this is about the entire demo of the distributed quantum services. If you have
Thank you.
any queries, feel free to ask.